lot for having me. I'm very excited to be part of this super interesting conference. So basically, I was thinking that I should give our audience today a bit of an introduction into a field that might not be that well known by everyone. It's an industry that has changed tremendously over the past couple of years. And it is an investment opportunity that has also emerged into one of the most interesting ones for generalistic deep tech funds. So over the past couple of years, there have been many funds that go into sector agnostic investments that are now also having space among their portfolio. I'm part of Alpine Space Ventures, which is a NewSpace technology focused venture fund. So we invest into anything around connectivity and data. But let me start with giving you a bit of an introduction of how space as an industry has evolved over the past 60 to 70 years. So many of you would know the space industry from the race between the US and the Soviet Union, which was an entirely politically motivated race. Who would be the first one to get into space? Who would be the first one to send humans on the moon? So basically, for 60, 70 years, the space industry was dominated or led by public agencies, so public space agencies and other governments, where science missions would be led by those institutions, and where basically commercial companies were just there to work around those missions, but there was never any other commercial use case for space. So you had actors including NASA, Roscosmos, and then later on you also had other agencies such as the European Space Agency, JAXA. Now we have India, China, the UAE, who became very active in the field. So the first large conglomerates from the private industry were Boeing, Lockheed, Northrop. Today you have Airbus, OHB, Thales. But overall, even in the early 2000s, governments represented 90% of all the space funding in the industry. Now, today, this has very much changed, and the trigger, or let's say the game changer for this, is basically that SpaceX brought down launch costs from more than 25,000 euros per kilogram for a payload to about 1,400 euros today, which was mainly because they made the rockets reusable. And one of our partners in the fund, Bülent Altan, he is, let's say the main architect behind the reusability of SpaceX's rockets. Then we also see totally new approaches to production and development. So you have a lot of miniaturization going on. Parts, pretty much everything needs to be made very lightweight, because every gram counts, and every gram costs you a lot of money when you send it into space. We are now talking about serial production, which was never the case before. You have technologies like 3D printing, which are supporting this. And basically, today it is possible to do things in a much cheaper and a much faster way. And then another trend that is supporting a more entrepreneur-driven space industry is that you have an increasing demand of data, and those data but also connectivity are enabled through satellites. So since 2010, the satellite market has basically increased fivefold. And since 2019, the number of operational satellites has risen to roughly 5,000 satellites, meaning that, this is really an evolution in the industry that is quite striking. Also, funding-wise, we have seen a very dynamic industry. So last year, for instance, space startups raised 14.6 billion euros, which is nearly double the investment of the year before. What I find super exciting about the space industry is that we're standing at the very beginning of an industry that is going to be huge. Already today, it's a 350 billion euros industry. Leading banks like Morgan Stanley and Chase Bank, they estimate that in just 10 years, the industry could represent 1.2 trillion euros. And if you think of the fact that today, only 10% of the global surface is connected, whereas half of global GDP depends on nature, we do think that Earth observation and connectivity will definitely grow in the next couple of years, and that it will become a global economic but also political priority. We also believe that startups are going to play a very, very important role here. And they are going to be the most innovative companies in the industry, just because they can take calculated risks. They can do things much cheaper and faster than others could, because the large conglomerates will not be as quick, and they cannot jeopardize their legacy systems by doing things cheaper and faster than they have done before. I always like to compare the space industry, or the potential of the space industry, to cases in other industries, where, for instance, you always had one use case in one particular industry, and you just cannot imagine today what the use cases of tomorrow will be, and how big of a dimension the industry will get. So, for instance, if you look at the internet industry, it all started out in the 1960s, 70s, when basically the US Development Agency or Research Agency wanted to connect their research centers so that they could communicate with each other. That was in the 1960s. Then in the 1970s, US defense took over, and basically the only commercial use case there was to create a decentralized and safe communications network with multiple nodes, so that no foreign intruder could bring that system into danger. Then this was very much the beginning of Silicon Valley, and at the very beginning in the 70s, we couldn't have imagined that it would turn out like this. Then we have we can look at the aviation industry as well, where in the 1920s, basically planes were made out of wood and canvas, and the only use case there was mail delivery. Then in the end of the 1920s, you had 6,000 passenger flights in the US, and this then rose to more than 1 million in the 1940s. Then afterwards, in the 1950s, defense and military supported the development of aviation, and this led to the invention of jets. So you can see how fast an industry is able to completely change its purpose. And I think for space, it will be very much the same. So as I mentioned, the only use case there was 60 years ago was very much exploration. So doing research and development in space and getting these results back to Earth. I believe that disruption happens when we rethink the ways we do things today, and when we're willing to open to change and innovation. So if we look at, for instance, 3D printing as a technology, and I think this is a very good analogy, because it caused disruption across multiple different industries, ranging from healthcare, to construction or fashion. I read that in the US, they have built a house within 24 hours through 3D printing. In fashion, you can customize footwear at scale. And in healthcare, obviously, you can print organs for students to test test surgery. This is also something that changed that industry. Now, what 3D printing allowed was really to accelerate the design process, bring down lead times from years to just a couple of weeks or even days. You can do things at a much lower cost. And one example here is, for instance, gas turbines. Before 3D printing, it took you more than a year to produce a gas turbine. It used to be one single piece of metal. Today, we make this out of much stronger but lighter structures, and we use less energy. And two examples that come to my mind, which are similar to the effects of 3D printing, and also departing from the fact that we are just totally redoing things and processes, is, for instance, our first portfolio company, Reflex Aerospace. Basically, instead of waiting for 5 years to get your satellite, paying multiple tens of millions, and then having a system that's up and running for 15 years, whereas you would have to make software updates much more often. Basically, what they do is they can produce a satellite not within 5 to 7 years, but just within 1 year. And this is because the manufacturing and production and development methodologies have changed completely. And a second example of that would be our third portfolio company, Blackwave. So what they do is that they replace very expensive key parts of rockets and satellites with composite parts. So basically, they replace very heavy steel and aluminium parts. They have a fully automated process, and thereby they also cut 95% of the waste that is produced by traditional means. So here you can see, this is a clear example of how changing things causes a lot of innovation and leads to disruption. Now, one other point that I would like to make is that space does have benefits for Earth already today. And in pretty much everything we do, you can find space technology as an anchor. So in telecommunications, for instance, satellite internet will allow to have a backup solution for connectivity. When we look at the Ukraine crisis, when undersea cables were attacked, satellite internet has proven to be a really, really effective solution to restore connectivity within no time. In automotive, we have satellite internet for autonomous driving, which is going to be a topic over the next couple of years. Automotive stakeholders will be able to proceed to software updates across their entire car fleet. We have agriculture, where you monitor moisture, air, soil, rainfall, and thereby you can optimize the output and also sustainable food production, and you can reduce the amount of fertilizer and herbicide waste. Then satellite internet or connectivity and also imagery allows for environmental monitoring. So you can have a much more accurate measurement of methane or other emission footprints. You can detect wildfires, for instance, at a very early stage, so that governments can better prepare, evacuate people, and then also prevent large-scale disasters. In healthcare, for instance, when you look at how proteins crystallize in microgravity, you can easily develop drugs in a much more efficient way. You can use remote sensing for a more accurate prediction of epidemic outbreaks, for instance. I think we've seen the importance of that over the past 2 to 3 years. And then obviously space technology and satellite connectivity also is widely used in the logistics sector, where through satellites you can actually monitor illegal shippings, drug trafficking. You can track ships that have gone lost, that are in remote areas. You can monitor the temperature of sensitive cargo, and it's also a means for predictive maintenance. And then when it comes to urban planning or smart cities, you can achieve connected traffic management systems, work on small grids. In the aviation industry, you get in-flight connectivity for commercial aviation, for emergency cases, and also to provide safety warnings. Then on the insurance side, what you can do is flood monitoring, predict earthquakes, and then work on tailor-made solutions. In the oil and gas industry, for instance, you can detect gas leaks early, monitor mining sites to protect workers. So this is where it's really interesting to invest at this intersection of space technologies and terrestrial uses. Okay, let me move on. Sorry. Now to basically give a bit of an overview of how we invest, or what it takes for us to make a positive decision to adopt a company into our portfolio. So I think that the investment criteria very much depend on the investment stage, whether you go in very early stage or a bit later. But essentially, there are a couple of fundamentals across all the stages. So when we look at the business, we always look at the market. Is the market big enough? And how does the company intend to penetrate that market? And also then, how does the company...
Thank you so much for these insights. We are actually already slightly or a lot over time. So if you want to find out more, basically, about what Lynn is doing, then definitely check it out. Lynn, thank you so much for being with us today. It was amazing to hear your insights. And we're now moving on, basically.